So let's try to find the inverse of this guy. And what did you just say?
Well, there's more than one instance of x.
We have more than one x term up here. So the trick that I was doing before is not going to work. So we're going to have to do this the long way. But we can do this because we're strong, right?
Yes.
We're invincible. So let's do it the long way. So what do you do first? Change f of x to y. So y equals 3x plus 2 over x plus 5. And then we do what? Right, so when I see y, it becomes x. When I see x, it becomes y. So 3y plus 2 over y plus 5. Now we have to solve for y, but y's in two spots. But this goes back to something we had a long time ago, where we really have a proportion. And what do you know about proportions?
Cross products are equal.
The cross products are equal. So when I do the cross products, these guys are going to be set equal to each other. So that means the cross product for x and y plus 5 is going to equal the cross product of 1 times 3y plus 2. Again, we still have two instances of y, so that's going to be problematic, but I'm going to show you a trick here. It's not really a trick, but it's the process that we're going to end up using later on this semester towards the end. So when I distribute, we get xy plus 5x, and the other side you're just multiplying times 1. If you can't multiply times 1, you're in big trouble. For a problem like this, anything that has y, and especially since this is just y to the first power, anything that has y needs to be on one side of the equation. If you don't have y, you need to go to the other side. So how do I want to do that?
xy minus 3y equals negative 5x plus 2.
Okay, so let's subtract the 3y over here to the left. And then we can subtract 5x and move that to the right side. So we have xy minus 3y equals negative 5x plus 2. You can't divide by x. What I want us to recognize here is that on the left side we have two y terms, right? But they don't combine to give me a single piece unless I do factoring. What's the common factor on the left side? So if I factor out this common factor of y, what's left?
X minus 3.
We have x minus 3. And so now, how many different places do you see y? In just one place. So how do I finish getting this y by itself? It's being multiplied times x minus 3, so how do I undo that?
You can divide by x minus 3 on the other side.
I can divide by this whole quantity of x minus 3, and I do this on both sides, like that. So now I get y is equal to negative 5x plus 2, all of that over x minus 3. And then to completely finish this, what do I need to do?
Replace y with
So the y goes back to that function, or inverse function notation. And there we have it. Was that crazy? I think the big trick here that you need to pay attention to is that once we get to this stage right here, you want to make sure that everything that has y goes on one side. If it doesn't have y, even though it has a variable, it's not y, that needs to go to the other side. That allows us then to take this common factor of y and you factor that out front like that. And once I do that, I'm able to divide by the other factor, x minus 3, and I can finish the problem. Now, just to kind of tie back in the stuff that we were talking about when it comes to inverses, I want to slide back up here and look at my original function. For my original function, my domain is going to be everything but what value? What makes this guy undefined?
negative 5.
So it's everything but negative 5. If we had more time to spend on the rational functions, we could also talk about what my range would be. Basically, as x gets really, really big, either positively or negatively, the plus 2 and the plus 5 don't mean anything, and you would have an expression that looks like this. But if you have 3x over x, what does that simplify to give you? 3, which means as x gets really, really, really big, the 2 and the 5 don't really matter, and you get an expression that's along the order of 3x over x, which means it's just 3. So you actually have a horizontal asymptote as you go out to the ends of y equals 3, which means your range is going to be everything but 3. So, as we were just mentioning, that means your horizontal asymptote is y equals 3. What is your vertical asymptote for this guy?
-5. X equals
X equals
-5.
-5. If we went a little bit further here, we could talk about what the x-intercept is. And you get the x-intercept by setting the numerator equal to 0, which means you're going to have -2/3, 0 for the x-intercept. And your y-intercept, well, what do you know about every y-intercept? No matter what function you have, what do you know about every y-intercept?
Is only 1.
For a function, there could be only one, if there is even one. What? It's going to be 0 something, right? So if I plug in 0 here, what do you get? You get 2 over 5. Do y'all agree? This is real. Yes, yes.
Sorry. Is it just a coincidence that they're like, so like with your answer that it's like flipped and it's negative now? Or is that
Flipped
like
to negative? Well,
I don't know how to explain it.
it does look like quite a coincidence that you still have 3, 5, 2, and a 1, but they're in different spots, right?
Yeah.
What were regular numbers are now coefficients and vice versa, right?
Yes.
Is that a coincidence?
So I'm gonna ask that's
It's not that much of a coincidence. You start to see patterns on some of these guys, right?
So could you just do it that way, or?
Do you really think that is the safest thing for you to do?
Yeah, I know, but I was just wondering, like, if it was. I don't know.
I think with enough practice on this, enough pattern recognition, you could say, okay, I know this is what it's going to be. In fact, that's what I do for some of these guys, partly because of what you're saying, but also because of what I want to show you here. Because we were talking about inverses, and that's what we were finding. This guy's domain was everything but -5. So let's talk about what that means for the inverse. So I want you to pretend right now that I didn't even give you this function. Pretend I didn't even give you that. I just gave you information about a function over here. What is the information that you can gather from this? If this is the domain of a function, what would its inverse be? Or what do you know about its inverse?
You know that it's the range.
We know the range should be the same as the original function's domain, right? Which would then mean I gave you the range for my function. What does that tell you about the inverse?
It's the domain of your inverse.
Then your domain is going to be this original guy's range. Right? Y's become x, x becomes y. You have a horizontal asymptote here. What does that tell you about its inverse?
It's the vertical asymptote on the inverse.
Well, what would the vertical asymptote be?
X equals 3.
Right, and that is a direct application of how y becomes x. And a vertical asymptote for the original corresponds to what on the inverse? Well, it corresponds to a horizontal asymptote of, instead of writing x, you say y equals -5. Are you with me on that? Remember, x becomes y. I'm saying that a vertical asymptote on the original is going to match up with a horizontal asymptote with the same number. I have an x-intercept here, which means I'll have what for the inverse?
0. Or your y-intercept is going to be 0.
Right, so I want you to understand this part. I said x becomes y, right? So this x-intercept becomes a y-intercept. Ordered pairs, however, get flipped around. Only the ordered pairs get flipped around. Okay? Notice I didn't flip around interval notation. Only the ordered pairs flip around. What was a y-intercept will correspond to what for my inverse? An x-intercept of what? 2/5, comma 0. And if you look at your inverse function down below, look at this denominator. What would make this denominator 0? That would make the function undefined. 3, and you see I had to remove 3 from my domain, right? If I look at my horizontal asymptote, I ignore these small numbers over here. What's negative 5x over x? What does that give you?
Negative 5 over 1 as you.
Negative 5 for the horizontal asymptote, which corresponds to that little skip that you have here, this little blip for the range. The y-intercept, if I plug in 0, I see 2 over negative 3, which is my negative 2/3. To find my x-intercept, you look at the numerator. If I set this numerator equal to 0, you would get 2 over 5.